Okay, so we're diving into our study of calculus, but before we really delve deep into calculus, let's talk about something for a second. It's a concept that we've been working on for a good while in high school math anyway, and maybe you've been working on this since middle school. But we're going to talk about something called the average rate of change. Now, I want you to take a look at the formula that's right here. All right, this is the formula for the average rate of change. And I want you to think about that for a second and think about that, what that looks like. Okay? All right. So, if you've taken previous math classes, and surely you have because you've gotten this far, in other math classes, they talked about average rate of change. All right, and they said that average rate of change was something like this, delta y over delta x. We know this to be from algebra 1, from algebra 2, even geometry. We knew this to be the slope, y2 minus y1 over x2 minus x1. Notice that what we do here is we just write it in function notation. Okay, so it's not much different than what you've seen before. All right, now we're given an example and we're going to take a look first at number 1. All right, and the problem here says, well, we've got y equal x squared plus 2x from 3 to 7. So this right here is our x1 and this right here is our x2. Our job then is to find f of 7 and f of 3 by plugging them in to the function. Okay, so what we're going to do is we're going to quite simply plug in. All right, so 7 squared plus 2 times 7. Okay, so that's 49 plus 14. That's 63. All right, and then we're going to take 3 squared, all right, plus 2 times 3, okay, and that's going to equal, that's 9 plus 6, 15, okay, so I'm going to have here, this right here is my y2, and this right here is my y1, 63 minus 15 over 7 minus 3, so that's going to be 48 divided by 4, which is 12. So my answer for the first problem here is 12. That's my average rate of change, my slope, if you will. All right, now I'm going to get into the geometry part of this in just a second, but let's continue with the next example. The next one gives us a function h of t, all right, and it doesn't matter if it's y or f or what have you, all right. It's the same thing. The variable might change. In this case, it's t. Maybe they're talking about physics and it's a time component of something that's oscillating, but it doesn't matter. So what you're going to do here, what you need to remember is that you need to have a working knowledge of the unit circle for this type of problem. So keep that in mind as you're going through this. I'm going to kind of take for granted here that you know the unit circle, so please be sure you know the unit circle. All right, h of t is sine of 3t, okay, and they want it from 0 to pi over 6, so let's say this is t1 and this is t2, okay. So what we need to do here is we need to find h of pi over 6 and h of 0. That's important. Okay, so what we're going to do is we're going to say, okay, sine of 3 times pi over 6 and sine of 3 times 0. Well, that's not too bad. All right, this one works out to be 3 pi over 6 is pi over 2, and then the sine here is going to be the sine of 0 because 3 times 0 is 0. So if you know anything about your unit circle, you know that the sine of pi over 2 is 1 and the sine of 0 is 0. So now we've got our t values, all right? We're going to say we've got our y values here. So these are like our y's and these are like our x's. All right, so we're going to take the change in y, and in this case, it's going to be 1 minus 0 divided by, and in this case, it's going to be pi over 6 minus 0. We end up with 1 over pi over 6. And I always tell my students when dividing fractions, always remember to KFC. What does that mean? Keep the first fraction, flip the second fraction, and change the sign from division to multiplication. So keep the first fraction, 1 stays the same. Pi over 6 becomes 6 over pi. You have 1 times 6 over pi, because then you change the sign from division to multiplication. You end up with 6 over pi. So the answer for this one is 6 over pi. So now I promised you I'd get into a geometric explanation. So let's take a look at this figure that's labeled here 2.1. So what we've basically done to find the average rate of change is we picked 2 points on the graph here, and then we draw a line that goes through both of the points. And that right there is said to be the secant. So in geometry, a secant line touches a curve at 2 points. Okay, so what we're doing in average rate of change is really finding the slope of the secant line. We're picking 2 points on a curve, and we're trying to find out, well, what's that slope? So this is what we're doing when we're talking about average rate of change. Once again, in other classes, algebra, geometry, algebra 2, they called this slope. All right, but now we're taking calculus. We're going to tweak the name, and we're going to call it average rate of change, because we're going to be talking about another kind of rate of change in just a bit. So if this video was helpful, as always, be sure to like and subscribe.